friends, welcome to my YouTube channel Manoj Networker. So today in this video I'll talk about basic campus LAN model allowing the internet access. So in the real time you might have aware we have multiple buildings and they all need internet access. So for our lab simulation purpose today, so I took two buildings, so building A and building B. So building A is completely is in production, so we have one access switch available and we have two computers. So you can see the computer IP addresses also 192.168.1.1 and 1.2. so let me first briefly provide you the overall lab and then we'll start the configurations. So actually all the building traffic will come to this main core switch of the building. So from this here also we need to connect to this core switch, but for a simulation purpose I just mentioned this building is under construction. So let's finish off all the configurations for building A first, and once they are able to reach the internet, so internet I am simulating here. So I have kept one server, so here we have 8.8.8 and we have google.com also. So here we need to make some DNS entries so that if I go and type this google.com, so he will directly get the information from here and we should get the information. So let's finish off the configurations in building A. So once that is done, we'll come to building B and we'll connect the cable to this multi-layer switch to this access switch, and then we'll finish it off the configurations. So end of the day this building computers also should go and access the internet resources that are available in the cloud. So you can see it here. So I hope the lab is clear, and in middle I am also using RIP protocol because we need to do some routing. Without routing, the connection from the server to the computers, it will not work. So any routing protocol we can use, like OSPF, EAGR, PR, even static routing also we can use, but for now I am using RIP protocol, routing information protocol. And the topics covered here is basic switching, the multi-layer switching also called as L3 switch, RIP routing protocol, and DNS server. So to complete this lab you should have basic knowledge on what is a VLAN, what is the switches, what is the routers, and how they will work. But commands wise I'll help you to configure. So first things first, let's go to the computers and let's assign the IP address. So 1.1 is here, 1.2 is here. So I think it's already assigned to the computer. So 1.1 is connected to the first computer, followed by /24 subnet mask, and 1.100 is going to be the default gateway that it will reside in this core switch. And same for 1.2. so 1.2 also I think I have already provided the IP address. So basic computer IP 192.168.1.1 with /24 followed by 1.100. so that 1.100 will come here. So here I am also using one access switch in building A. So here the job of this access switch is, so here we no need to configure anything, it is just acting as a mediator of connecting from that computers to the core switch. Okay, so now here in both of these buildings, so we no need to make any configurations because all are in VLAN 1. So this computers also in VLAN 1, so these computers are also in VLAN 1. So I haven't make any VLAN changes here, so I'm just kept all those things in VLAN 1. So moving further, so let's go to the configurations on the multi-layer switch. So this multi-layer switch is also called as a core switch for my company. So let's go to CLI. Okay, so this is important. So by default these multi-layer switches will come up in power off mode only. So Cisco has made that like that because we need to give the power first, then only it will work. And in the real time also we will get two power cards. So why we need two power card means, like let's say in real time we have power sources from different companies or from different transformers. So this is a power card 1, this is a power card 2. So since this is a core switch, so always 100% uptime should be there. So because if this core switch went down, my complete building infra will go down. So that's why the power card P1 will come from transformer 1. So power 2 it will come from transformer 2. 2. So even like let's say if this power source 1 went down, so I still have the connectivity. It's just like they will act as a backup. So that's why Cisco will provide 2 power cards. So it's up to you how many power cards you want to use. So based on your requirement, you can use it 1 or you can use it 2. So that's completely depends on the company who are managing the network infrastructure. So just to skip this mode by typing no. So this switch is going to be my core switch. So just change the host name to core switch, and now let's minimize this one because we want to see the topology parallelly and we want to configure it. So we need to configure 2 IP addresses here. So interface gi 1/0/3. so this should go to my LAN. So no shed IP address. Okay, so we need to issue no switch port. So by default these switch ports will come as a switching ports. So we need to issue no switch port so that now we can assign the IP address. So IP address is going to be 192.168.1.100 with /24 subnet mask. We can even provide the description also. So LAN facing switch, something like that. Okay, so any description is fine. Or we have like other interface gi 1/0/1. So here also we can make the description towards the router. This is just for your knowledge purposes. So in real time we will use this kind of descriptions so that we can easily identify who is sitting where and how they are connected. So now no shed, so IP address, so 172.16.1.2. so please follow the topology. I have already provided the IPs there. So this is the IP address I am using, 172.16.1.2. so 172.16, there should be space 1.2. okay, no switch port maybe, and IP address 172.16.1.2. yes, now it's accepted. So now let's do the no shut. I'm not sure if I have done that or not. So we also need to do no shutdown. Yeah, that's clear. So 2 IP addresses for the 2 interfaces. So now, and still routing is pending. I'll come to that routing. First I'm just assigning the interface IPs. So let's also go to this router, and now this router is acting as a mediator towards my server and towards my switch. So config t, so let's assign the IP address quickly. So gi 0/0/0 no shutdown. IP address is going to be 172.16.1.1 with /24 subnet mask. So this is the IP towards my switch, and it has one more port gi 0/2. so that is going towards the internet server. So no shutdown, and that interface IP is going to be 8.8.1. so we can use any IPv4 address, so and it will absolutely work. So 8.8.1, excellent. So now the final step is go to this server. So let's assign the IP address to this server. So the IP address here is 8.8.8. so I have already provided the IP to this server 8.8.8 with /24 subnet mask. So the default gateway is going to be the router address 8.8.8.1. so let's go to this middle router. So let's try to ping the server first of all, because ping will ensure that we have the connectivity. So I am pinging to the server. Let's see if it will goes. I hope so. Yes. So now I have the ping reachability. So from the router, let's also ping to the switch IP. So 172.16.1.2 in this case. So hopefully this should go, because router knows both of the people. Show IP interface brief. If you see 172.16.1.1 is a router IP, so this is going to be the switch IP. So it has the connectivity. So 8.8.1 is the router IP and 8.8.8 is the server IP. So now let's go to your switch. Let's go to our computer and let's try to ping 8.8.8. let's see what will happen. First we'll try to ping to the default gateway, because we need to check if the default gateway is reachable or not. So let's check the default gateway 192.168.1.100. yes, absolutely fine. The computer is able to talk to my core switch. But if I try to ping 8.8.8, so okay, now if you see we are getting some response from the gateway telling destination host unreachable. That means I am unable to go to the destination. Let's see what is the problem. So the problem is here there is no routing that's been configured between the devices. So actually this switch itself doesn't know who is 8.8 network. So now we need to create one routing protocol, any routing protocol, so that first this server should be learnt by this switch. Then only if this switch will know, then all the computers can go and talk to the internet. So let's configure the routing on the multi-layer switch first, followed by our router. So to do that, so let's see first show IP interface brief. Let's see what are the networks it knows. So it knows about two networks, 172.16.1.0 and 192.168.1.0. So now first let's enable router RIP. So I am just doing the changes on multi-layer switch. Now first I am going to the multi-layer switch. I am configuring the RIP protocol. So router RIP, sorry, conf t router RIP. So it knows about two networks. So the network is 192.168.1.0 network, that is the LAN network, and it also knows about one WAN network, 172.16.1.0. we can also use no auto summarization. And now let's quickly see the configurations. So section RIP. So if you use this command show run section RIP, we can only see the RIP configuration. So in this router we have router RIP network 172.16.0.0, network 192.168.1.0, and no auto summary. That's fine. So now in the same way, let's go to the router, and we also need to configure the routing here. So conf t, so router RIP network, it knows about 8.8 network, and we can use no auto summarization, no auto summary. And network, it knows about 8.8.8. It knows about 172.16.1.0. So now let's see if the switch learnt the 8 dot network. So how to do that means, let's go to this switch and just check show IP route. Yes, if you see show IP route, now it's learning 8.8 network, or you can also type show IP route RIP, so that it will show what network it is learning. So now from here let's try to ping 8.8.8.8. let's see what will happen. Now my switch is absolutely able to ping the the 8.8.8. so now let's go to this computer and let's try to ping. So before that, let's go to the router and see the routing table here also. So show IP route. So here also it is learning the topology. You can see R. So R stands for RIP protocol, because the routing is learning from RIP. So that's why you can see the show IP routing table. So it's the code is starting with R. Or we can also filter with show IP route RIP, so that it will only display whatever. This is the building one network. So 192.168.1.0 belongs to building 1. So and that is showing. So yeah, we can also use show IP protocols, so that the router will show you which routing protocol it is running at this point of time. So there are many useful commands to do in the real time. So yeah, without wasting much time, let's go to this computer, and now let's try to ping 8.8.8. hopefully it will go now. So that's the power of routing. Now if you see, since the core switch learned 8.8.8, this computer also able to ping 8.8.8.8. so now let's go to, we need to do some changes on this router. So let's go to this router, let's enable the services, go to HTTP. So now just ensure both HTTPS is on. So go to this image. So here instead of Cisco packet tracer, so I'll type my YouTube channel. So Manoj Networker, and welcome to. So just don't change any other things. So keep the font complete as it is. So whatever the information you would like to type, you can type it here. Welcome to Manoj Networker YouTube channel. I mean anything is fine, and just save the changes. So now I am just trying to show the DNS part. So now the changes are done. So let's go to these computers. So any computer basically 1.2 I am going. So just try to ping 8.8.8. yes, it is pinging. So what we can also do means, so we can go to the web browser on the computer, went to web browser and just type http 8.8.8. let's see if I am getting the requested web page. Now if you can see, so I am getting Manoj Networker, my home web page. So welcome to the Manoj Networker YouTube channel. So that means they are able to, these both computers are able to successfully go and reach the internet, and that's how the web pages are displaying. But the problem is, like let's say, since I am typing 8.8.8, so what's happening here is, so the traffic from this computer is going to this switch, and this switch is forwarding to this core switch, and it, since it has a RIP protocol configured, so it is going and talking to the 8.8.8. so here, like let's say Manoj Networker is one application, so that is running in the world of internet. Okay, so this server I have hosted my application called Manoj Networker, so that's why in this computer, so Manoj Networker IP address is 8.8.8. so if I am asking for 8.8.8, so that contents of the manojnetworker.com YouTube page is coming. But in real time we will not type like let's say if I go to any browser, I'll type https flipkart.com, or if I type https amazon.com, but we will not remember the IP addresses of the given website. So like let's say if instead of 8.8.8, if I type my web page name manojnetworker.com, so now if you see, we are getting host name unresolved error. So if I type https 8.8.8.8, I am getting the web page manojnetworker.com correctly. But if I type the browser level with http manojnetworker.com, we are getting host name unresolved. So let me explain what's happening here. So the devices doesn't know that 8. Since the computers are able to talk 8.8.8, but they doesn't know 8.8.8 is also having the Manoj Networker application. Okay, so that is been missing. So that's how the DNS will come to picture. So DNS means domain name system. So we as a humans, we can remember the FQDNs like flipkart.com, amazon.com, facebook.com, youtube.com. so those things we can remember. But whereas the computers, they will computers or network devices, they will always work on IP addresses only. So even though if you go and type 8.8.8 in the browser, we will be getting the global DNS only. So if you go to https 8.8.8, so you will be getting the global DNS from the Google. So that's why we will be using in the real time always 8.8.8 if you see, and it is getting diverted to the dns.google.com. or if I type normal google.com also, I will be getting the page. So that means what's happening means, so even though I am typing 8.8.8, you see the browser is changing to the dns.google.com. so that's how the DNS will come to picture. So to solve our lab, what we need to do, we also need to ensure now this server, we also need to make this server as a DNS server. So DNS server, we need to tell 8. When anybody is asking manojnetworker.com website, you need to respond. So how to do that? So let's go to this server. So let's ensure the DNS services is, go to services, go to DNS and ensure the service is on. Name is which name? So I want to type http manojnetworker.com or flipkart.com or amazon.com, anything. So address is going to be my server address 8.8.8. very simple. Let's create a record. Or if you would like to do google.com, so http google.com, so this server should respond for everybody, then we can add it like this. So you can create n number of records. So now let's also save it. Okay, now let's go and try finally from the computer. Let's go and try manojnetworker.com and let's see what's happening. I just went to the computer one. I just refreshed the content. Now if you see, so even though if anybody is asking for manojnetworker.com, so I am able to see the contents of the thing. So this is possible with the help of DNS. So I hope is like enough to understand what I have done here. So moving further, let's connect this building B to this switch. So and let's finish off the lab. So you can use gigabit 0/1 or any port would like to, and here I am using 192.168.2.1 2.2. So here we need to use 192.168.2.100. so let's go quickly to that multi-layer switch and let's assign the IP address. So I hope you are following. So config t interface gi 1/0/2 no shutdown, IP address is going, okay, no switch port we need to do, and IP address is going to be 192.168.2.100 with /255.255.255.0. very good. So I think that's all we need to do. Yes, and on the router RIP we need to advertise this new route, so that is missing. So router RIP network, because the new network is added to my production today, so 192.168.2.0. so let's quickly see the configurations. Show run section RIP, yes, 2.0 is there, and let's see if the router is learning 2.0 network. So now if you see what's happening means, so this is a new building. Now earlier it is in under construction, now it is in construction. So I have connected this network. So now it's a completely 192.168 2.0 is a new network. It is announced, the core switch is announced. So by the time, with the help of RIP protocol, this router should learn that 2.0 network. So let's see that. So how to validate means, go to that router and look for show IP routing table. Enable show IP route, and yes, if you see already the 2.0 started learning by the topology. So the one thing is missing is, so let's go to this computer and let's try to ping. I think it's already working, but just for your confirmation I can ping. So this is how within Hazel Free we can add the production multiple buildings. So I hope the session is informative. So if you have any feedbacks, do let me know. Thank you.